propagation. Okay. Then this is the Edinburgh. Equation 1 is partial y, partial x squared equal to 1 over c0 squared, partial y, partial t squared. Okay, this is Gaussian equation. And my initial condition is I give y xt is y x at time equal to 0. Okay, is equal to f x plus gx is a function of ux. Okay, so this is my initial condition of displacement. I also have an initial condition about the velocity. Okay. Here we assume y is okay, maybe later. It's a function of ux. Initial velocity we are called the vx. Okay, this is initial. And in my later notes, we also have expression as traditional, is u0x and u0 dot x. Okay, so there's a function of x. I will use u0. Okay, and okay, use this for the current physics for you use a u as a variable. Okay, so there's u0 as the initial condition. But here, last week, we use this as a ux, and use a function of u and capital V as for velocity. Okay, so let's recall the solution. If we assume f equal to xt is f x minus c0 t plus g x plus 0 t. So this is my solution type. Okay. Then after we do the variable change variable, we assume c equal to x minus c0 t. Eta is x plus c0 t. Then we change this governing equation into the outer doing the derivative, and we need to solve y partially to c eta equal to 0. Okay, so from this solution, I've do integration about the eta. So y c equal be a function of c. Yeah. Okay. So we integrate the eta, only the function like this for partial y c. Partial eta is equal to y c eta equal to partial f c partial eta. Certainly 0 is fine. Okay. Then this integrate further, I will have a y as a function of c plus the function of eta only. Okay. So this function is the integration of f to c to c. you get another F format, right? This is a F, capital F, after integration you get a small f. So that's why. So this is my solution for the wave equation. And you put it back, you got y x t. It's a f x minus c0t plus g x plus c0t. So this is my solution, right? So from this solution, I need to use the initial condition, right? So last time we say y x at t0 is equal to function of fx, because t is like that, plus g of x. And this will be equal to the initial condition y0 x, right? y0 x. And we call this, or we name as a ux, is a function of x. Another initial condition is a y dot at x0. That will be y dot, okay? So that will be what will be right? Okay, so x0 will be partial f x minus c0t partial t at t equal to 0 plus partial g x plus c0t partial t, right, at t equal to 0. And this will be equal to partial f partial eta c at and partial c partial t, right, at t equal to 0 plus partial g partial eta partial t at t equal to 0. Okay, and partial f partial c at and the partial c partial t at t equal to 0, right? Plus partial g partial eta partial t. And partial c partial t is minus plus minus c0, right? And this is c0. And this will be partial f for t equal to 0 is partial x. Okay. And this will be will be partial g, partial x. Alright, so we have yt, y x0 is equal to fx plus gx, okay, equal to ux. Y dot x0 equal to c minus c0 f prime plus c0 g prime equal to Vx. Okay, so this is known, it's given. Okay. So initial condition, the whole domain, any x location, it has a value as initial condition. Okay. So initial condition related to every point in the x domain, right? So from this solution, we can solve the fx and gx, the function format. Okay. So once we got this, then we put x into c and eta. Then we'll get put the x equal to minus solution. So from this, I can get fx equal to minus 1 over 2c0. Okay. Okay. So from this equation, I integration both sides by x, so I can change this to f. Okay, so we'll get fx minus gx equal to 1 over c0. My negative integration about vx, okay. Or change the dummy variable c in c, for example. If you don't like c, you can choose any alpha, the alpha, okay? And alpha is from the x0 to x, the whole domain, okay? The x, this is a range of the x, from x0 to some point, okay? So this is the initial the location, the range, okay, range, okay, x0, yeah. And fx plus gx equal to ux, right, ux. So you can solve this equation, then you can get the fx and gx. So from this, we solve this. We can get a form of fx as 1 over 2c0 integration from x0 to x, b to c plus half ux. And the gx, the form is 1 over 2c0 from x0 to x, and this b integration, and plus half ux. Okay? Or I can change this format to x by replaced by xc0t. Okay? So over here I can change. Okay? So that will be this minus 2c0, and the integrand from x0 to x minus c0t. Okay, so this is a fixed value. And b to c plus f ux. Okay, so this given function, given function without time, no time here. But be careful, this here we have time t here. And the gx plus c0t equal to 1 over c0, and x0 to x plus c0t. Right? And V to C, D to C, plus half Ux. Okay. So this is an initial velocity function, velocity distribution. On X. So this is an initial displacement distribution on X, the range. Okay. So this is time axis. And this is at x0 to x. This is my range for my domain. Okay. And I have an initial velocity, and this axis an initial displacement distribution. Okay. So I may have this U x is a initial displacement, or I may have Vx as initial velocity distributed on the t equal to 0. Okay? Yeah. So we see what happened. So this is F and G. So my solution is superposition of these two. Finally, I get the solution yxt as 1 over 2c0. Okay. And you superimpose these two, and you can change the sign minus to change this to lower limit. Okay? Lower limit. Okay. So from this to x0 and from x0 to x plus ct. Okay. So now actually this is not x0 is just an intermediate point. Okay. So suppose it's depends on range. And this is a arbitrary point. Okay. Anyway, so you superimpose from x minus ct, x plus ct. Then the function f is c, e is c, plus x minus c0t plus u, x plus c0t. The c equal to x minus c0t, eta equal to x plus c0t are called the characteristic of equation 1. Then sometimes it's called, this will be a line function. Line function in xt domain. So sometimes we call this a characteristic line. Okay, it's a line. So along the x minus c0t equal to a constant, any value, okay? F to C, this function has constant value, right? Because this is equal to constant. Okay. So this function will be constant. So that means for this is a x-axis, this t-axis. For any point, xt, right? It has a solution, okay? Solution of that form, okay? Then this is a initial condition. So to go through the, on this line, this is a C equal to a constant. For any point. This point on this line, it has the C equal to constant, right? And on this line, this is theta equal to a constant. Okay? Right? So this is okay, constant that, for example, we call the beta. Okay. And this is a constant equal to alpha, for example. So this line is x minus c0t equal to beta. Right? Yeah. So, yeah. So what I mean? This is a x plus c0t equal to alpha. Right, this line. So that means the solution of this value will, at this time moment, okay, it will use the initial value at this range. For any given point, it will use a range u to c, the function